Hello, my name is Kristen Tone, and this is my Physics 2211 Lab 1 report. We will first look at our purpose and principles used in conducting this lab. The purpose of the lab was to observe the principle of momentum by carrying out an experiment in which an object, in this case a bottle, was in motion in the positive x direction. The velocity was calculated based on the position changes in the recording of the object using the updated position and updated velocity equations, which were in turn used to determine the net force. The results of this experiment found that the observed and predicted velocity of the object had a positive constant velocity and zero net force on the bottle. To graph these findings, Tracker was used to gather the position and time data points of the video of the bottle moving across the table or the observed calculations. GlowScript was then used to determine the predicted calculations, using some of the data gathered by Tracker and the updated formula equations previously mentioned. The results of the observed and predicted movement can be seen graphed here, where they have very close rates of change in position over time, although the observed rate is slightly faster. We will now explore how these final results were calculated. When setting up this experiment, the system was determined to be the bottle depicted here, and the system was a whiteboard and meter stick. The equations that were used in this experiment are the updated velocity formula, the updated position formula, the net force equation, and the average velocity equation. We would then use Tracker for the collection of the observed position and time values and GlowScript for predicted value calculation. The initial conditions for velocity, time, and position are listed here and were found using Tracker calculations. The experiment assumed no friction or air resistance for simplicity of calculations and to better demonstrate Newton's laws, which quantified the movement occurring in this experiment. These values found using Tracker and the equations were then used in GlowScript to code the predicted model. Here we see the code for the predicted graph initialization, in which the object's initial position and velocity vectors, the initial time value, and the change in time between the observed data points were inputted. Then, by setting up a while loop that lasted until the final time found in Tracker, the object's final velocity was found based on the updated velocity equation. This equation finds final velocity to be equal to initial velocity plus the product of acceleration and change in time. Because the object was observed to have no acceleration in the x direction, the final velocity was simplified to be equal to the initial velocity. The ball's final position was calculated using the updated position formula, where final position is equal to initial position plus the product of the ball's velocity and change in time, which the program calculated using the initial inputted values. Based on this explanation of the experiment and calculation, we can now look more closely at our final graph comparing the observed and predicted position versus time data. We see the two models are quite similar, as the position data for both moves in the positive x direction and their slopes indicate a constant positive velocity. However, in the predicted model there is no variation in the velocity, unlike the slight variation seen in the observed model. Also, the observed model does seem to have a slightly faster change in position over time than the predicted. These differences can be attributed to possible errors in the experiment, including inaccurate data having been collected in Tracker, human error, or an uneven surface in the surroundings in the experiment. In conclusion, this experiment allowed us to see Newton's second law in action, as the consistent change in position over time of the bottle rolling across the board resulted in a constant velocity, which indicates a zero net force based on the net force equation, force equals mass times acceleration, as a constant velocity means acceleration is zero, and the carrying out of this experiment was extremely close to what is predicted by these physics principles. Some additional questions can be brought up by this experiment. Firstly, we can ask what would happen if the orientation of the axes were changed for the position. In this case, the velocity would remain the same based on the equation velocity equals change in position over change in time. The direction of the position does not alter the magnitude of the velocity. The position graph would simply change to show the object moving in the negative x direction. A second question is whether it's possible to determine the number of forces acting in this experiment. While we know the force of friction and air resistance are present, they are not acknowledged. Additionally, the force of gravity is not acting in the x. Overall, there are likely other forces that we are unaware of from the surroundings, although we do know that these forces are equal and opposite because of the net force of zero, as determined by Newton's second law. Thank you for watching.